Hi kids. I thought it would be easier if we did these notes via video again after the first chapter test. That worked out pretty well for chapter 2. So at any point feel free to stop the video and ask questions or replay anything. Your paper should be a little bit clearer than this. I had a little trouble with my printer. So this is the first set. We're going to try to start numbering your notes for you. This is set number 1. For chapter 3. So the first thing we're going to talk about is parallel lines, which you should be really familiar with parallel lines, but we're going to go a little more in depth with the idea of what parallel lines are, not just, oh, they don't touch. We want to say that they are coplanar. We have learned the word coplanar this year, and coplanar basically just means that they're on the same plane. They are coplanar lines that do not intersect. So we're going to add to that idea of parallel lines are lines that excuse me, that do not intersect. They are coplanar. They have to be coplanar. We use arrows. So you can see these arrows right here. We use arrows to indicate that lines are parallel. If there is more than one set of parallel lines, you may see double, so it may look something like this to indicate parallel lines as well. The symbolic notation, if we look, we know that we name lines using 2 points. In the arrow above, line AB is parallel to line CD. Parallel planes are planes that do not intersect. And we use the same sort of idea. You can see that this is plane J, so plane J is parallel to plane K. Skew lines are probably a new term, and I like to kind of think about skew lines as if you think about the corner of a classroom, and then if we look at the opposite side of the classroom and we look at where the wall and the floor meet, those would be considered coplanar. So this one right here and that one right there. So they are, okay, so they are non-coplanar. So non-coplanar, remember, they are not on the same plane, lines that do not intersect. So for example, we can use this TP right here. So TP does not intersect with this QR. This one does not intersect with that one. And there's multiple of them that you could use as an example. We could say this PS down here. I'll switch to another color. This PS right here. PS and VR are an example. And another example would be this WS back here and this PQ up front. So those are segments that are not in the same plane that do not intersect. Like I said, feel free to pause at any point in time. I'm going to try to move quickly just so I can leave this video under 15 minutes. The next example here, we are looking at this figure, and it says to name all segments parallel to AE, segment AE. So if I look at segment AE right here, what would be parallel to AE? Well, remember, they have to be in the same plane. So FB would be a great example of a segment that is in the same plane and parallel. Okay, so continuing on, the segments that are parallel to AE, HD back here, you can see on this side that that segment would also be parallel on this plane over here, so HD. And then we would have another line parallel in this one over here, GC. When they start talking about parallel planes, you're talking about a box. So for example, if we have EHG, EHG, which is the top of the box, plane EHG is parallel to the bottom of the box down here, So we have the top of the box up here and the bottom of the box down here. And we can name that any 3 points that don't make a line. So we can do plane ADC. We can look at this plane over here, plane EAD, and the plane parallel over here, plane GFB. And then name all segments skew to GH. Now remember, skew means that it can't be in the same plane. So we are looking at this guy back here, and anything that is skew to GH. So anything that's not going to be parallel to it, anything that's not going to touch it, not in the same plane. So the first one I'm going to look at is FB, which is this one up here. So you can tell this one's going up and down, that one's going left and right, and they are never going to touch. So FB. AE is another example. This one is going up and down here. That is on the back of the box going left and right. So AE is another example. AD, this line right here is going this way. That is up there. So AD. And if you're not sure, best thing is to look at a box, and you would see these pretty clear. So if you need a box to look at or a rectangular prism, just let us know. BC is my other one right here. So that is never going to touch. So BC is skewed to GH. Okay, so in this next figure, you can see that this is a pentagonal prism. It's got 1, 2, 3, 4, 5 sides, and it's got 2 pentagons connected by rectangles. So in this pentagonal prism, the first thing says is to name all segments parallel to JK. So if I look at JK, JK is right here. So I need everything that is parallel to JK. There's actually only one that is parallel to JK, and that is this over here. You can see in that bottom rectangle, those are the ones that are parallel to each other. Everything else is going to have a little bit of an angle, so the only one that I'm going to list is segment OP. Now don't forget, you could have named that segment PO as well. That segments can name by their endpoints in any order. In part B, it says name all the segments parallel to NS. NS is right here. So I need all of them that are parallel to NS. There's actually quite a few of these. If you go all around the pentagon, you'll see that MR or RM is parallel. This LQ or QL is parallel. KP is parallel as well. And then this guy down here, this OJ, is parallel. So you can see that they connect the pentagons, so they are parallel. In this particular problem, it says name a plane parallel to JKL. And if I look at JKL, JKL is this pentagon on the end. So where is the plane that is parallel to that? It is the pentagon on the other end of the prism. Remember, to name a plane, you're going to use any 3 non-collinear points. So you're going to use plane, and it could be S, R, Q, P, or O. You can use any 3 of those 5. So I'm just going to use S, R, Q. And then finally, this last one here. Name 4 segments skew to RQ, to segment RQ. Remember, skew means it can't be in the same It cannot be in the same plane. They have to be non-coplanar, lines that never intersect. So, and I only need to name 4 of them. So the first one that I'm going to look at is line LK, which is this one over here. It's on this plane. This is going up and down. That's kind of going to the side. So that is never going to touch. SN is also another one that's never going to touch. So this one over here and this one over here. Remember, those are on separate planes. This one has kind of got an up angle to it, so it's not going to touch the other one. Another one would be this NJ. This JO down here, JO is never going to touch. So that gives you 4 of them. Could you name others? Yes, you could name others. We could say JK as well. So there are others that you could name. Okay, so we have flipped to the back. And the first thing, we only have a couple minutes left on this, so I'll probably end up doing part of this and then switching videos. So just kind of bear with me on that. The first thing that we need to talk about is what is a transversal. And a transversal is, this is the example right here of that transversal. And it's a line that intersects 2 or more lines. So you can see that we have line L right here and line M, and you can see that they intersect line T here and here. So line T is our example in this picture. Angles formed by transversals. These are going to be really, really important, and we are going to practice these a whole lot in Chapter 3, and basically these are essential for you to know in Chapter 3. If you don't know these, it's going to be bad news. So the first one that we're going to look at is the idea of corresponding. And you can see it says angles on the same side of the transversal in the same position. So what I want you to look at is the idea that we have the 2 lines here and here that intersect that transversal. And remember, our transversal is that line T right here. This is our transversal, and I'm going to kind of color it a little bit so you can see. Hopefully that's a little bit different color for you. I can't tell on my computer. Hopefully it looks a little bit different to you. So when we're looking at this, what we want to think of is on the same side of the transversal. Now, it could be left and right. It could be up and down. It just is dependent on which way the transversal is. So because in this particular one, our transversal is relatively up and down, the same side would be to the left or to the right and in the same position. What do we mean by that? Well, I mean to the left is angle 1. To the left and above line L is angle 1. And then if I look at where it intersects down here, to the left and above is angle 5. So angle 1 and angle 5 would be considered corresponding angles. They are both left and above. They're in the same spot. We're going to look at this set of angles, and then this set of angles is really what our goal is. Another set of corresponding angles would be to the right and above, to the right and above. So angle 2 and angle 6. Angle 2 and angle 6. So then we want to go to the left and below. Angle 4 is to the left and below. To the left and below. So angle 4 and angle 8. And then lastly, to the right and below is angle 3. To the right and below is angle 7. So angle 3 and angle 7. And I'm going to go ahead and end this video. Please continue on the next video to finish up your notes.